So using this ray aspect of light, we will look at first what's called the law of reflection. Now, reflection occurs when a ray of light bounces off some object, as opposed to transmitted through an object. So if you have an object like your bathroom mirror where light bounces off of it, or like the wall or my face, right? The idea is you can see my face because light from the room is bouncing off of my face and going into the camera, right? Light, look down at your shirt. Light you see is bouncing off of your shirt and going into your eyes. If there were no light bouncing off of your shirt, you couldn't see it. It would look black. So the law of reflection is fairly straightforward. It's the simplest law we'll be looking at in these concepts of geometric optics. Now, basically the law of reflection states that the angle of incidence is equal to the angle of reflection. So theta, the angle sub I, which is the angle of incidence here, is equal to theta sub r, which is the angle of reflection. But these angles, how do we measure them? Well, we measure them from what's called the normal to the surface. Now, back last semester when we talked about friction, we had to understand what the normal was. A normal is just the perpendicular direction above some surface. So if you have some inclined plane, some flat inclined plane, the normal is perpendicular to that surface, right? If it's flat, the normal will be pointing vertically. If the surface is vertical, the normal will be going horizontally. So we have to figure out what the normal is, and the normal as measured by where the ray intersects the surface. So for instance here, let's look at a simple plane mirror, like one you would have in your bathroom. So the little hash marks on the right mean that that's the back end of the mirror, so no light can get back there. So here's the reflective surface in the front, so we're staring at the mirror in this direction. A ray of light, for example, if you have, again, your little laser pointer as an example, you shine your ray of light upward at some angle and you hit the object. So you're not going straight at the mirror, you're kind of firing your laser pointer up. It hits here at that interface. What happens to that ray? Does it pass through? Well, no, it's reflected, it bounces off. But what direction does it bounce off? Well, in this case, we have to find out what the normal is. Well, the normal is this dotted line, right? It's perpendicular to the surface. So the angle of incidence is the angle between the ray, the incident ray, and this normal. So here it's about 30 degrees or so. Well, if this is the angle of incidence, the angle of reflection is equal to that. The angle of reflection is measured from the normal on the other side of the normal. So the ray bounces off. This is the direction the ray will take, 30 degrees away from the normal on the other side of the normal. So if these were really indeed 30 degrees, this total difference here would be 60. So we have to figure out what the normal is as measured from that position, and then measure our angle of incidence and angle of reflection. So what if our mirror surface isn't straight? Here I have a curved mirror. And I have three rays coming in that are parallel. Here's a horizontal ray coming in, here's a horizontal ray coming in, and here's a horizontal ray coming in. What happens to those three rays? Well, again, we have to treat each ray separately. We have to figure out what the normal is at the point they intersect the surface, and then measure the angle of incidence and angle of reflection. So for this middle one is coming straight in towards the mirror. The normal here drawn by the red line, the red dotted line, is parallel to this angle of incidence. So the normal is coming straight off. The angle of incidence is going right along the normal, so the angle between them is 0. There's no difference between the angle of incidence and the normal. They're coming in at the same direction. So if the angle of incidence is 0, the angle of reflection must be 0. Which means that a beam here, this central beam, comes in and bounces directly back out along its inward path. So it's reflected directly back along its inward path. The equivalent would be shining a laser pointer flat directly at a mirror. The laser pointer would hit the mirror and come right back and hit the laser pointer. What about these other two? Well, here we have a ray coming in, hitting this point. At this point, the normal is drawn by this dotted line. So there is some angle of incidence, it's not 0. And the angle of reflection is the same as the angle of incidence measured on the other side of the normal. So this ray would bounce up. Down here, the ray would bounce down. So you can see how parallel incoming rays, I can disperse them. I can send them off in different directions with a curved mirror. Now, this actually happens all the time, not in mirrors, but just in walls. So look at the wall of the room you're currently in. It might have wallpaper or paneling or paint or whatever. That wall, you can see it. Light is reflecting off of it, but it doesn't act like a mirror. Well, why not? Because the surface of the wall is very, very bumpy at microscopic levels. So when light strikes it, parallel beams of light strike it, the light spits off in all different directions. This is called diffuse reflection. So this diffuse reflection basically is what gives the walls the color. You can see the light bouncing off of it, but it's not a mirrored surface. To get the mirrored effect, you need to have a mirrored object. You have to have a very smooth surface that reflects all the light in different directions. So again, for the surface of your wall, this might be the surface of your wall on a microscopic level. As parallel beams of light come in and strike the wall, even nearby beams of light will bounce off in all directions. That's called diffuse reflection. That's why walls don't look like mirrors. You need a very smooth surface in order to get that mirrored effect. And there are ways of getting that very smooth surface. Mirrors, of course, glass with some kind of a silver or aluminum backing can do it. Still pond, the water interface can reflect some of the light up and act as a mirror. So you have, that's called specular reflection, when you actually have a mirrored surface that acts like a mirror, that bounces all the light back at the same direction. So we have diffuse and specular reflection. Again, but the law of reflection basically is this simple relationship. Angle of incidence is equal to the angle of reflection, and those angles are measured from the normal where the light beam strikes that surface.